Hello again. Welcome back to Information Storage and Retrieval. Today we're going to work out a few new processes. We're going to add some new tools to our information retrieval library that we've been working on. Pardon my situating sounds. And we're going to actually wind up indexing. We're going to actually build a complete index today. It's going to take some doing, and there's plenty of steps along the way, so we'll be stopping to explore things in the console like we usually do. But the idea being, we're going to take, instead of, last time we worked with a few ways to process text, right? We changed, in fact, I can even pull that up if my system cooperates. I think I can pull it out. You can see my video there. Right. So we had some raw text, right? And we figured out how to trim it, how to lowercase it, how to remove punctuation that we decide, and then normalize that text. So, and then ultimately tokenize it into a set of terms, correct? So, today we're going to talk about doing this not just to one single string, one single document, but we're going to do it to a whole set of them, which will define how to split them up in the process. So what we'll be working out is how to convert a set of raw documents, just a bunch of text, into a split set of documents for one thing. So we can see our documents are actually separated, right? They are in separate strings. Well, actually, that's a little ugly. Let me delete back to something sensible. Our documents will be split into individual strings, right? This is an array, right? So this is a list of items. In fact, to show you how that one works, to make sure you're up to speed, if we, let's see, what's the name of that one, just for now, while we explore the initial conditions here. The name of that second one is docs. So if I do my helper function, which again, you don't really need to know everything about that helper function, just know that you can use it to go grab things from document by their ID. So if I go grab the docs, okay, there they are. Let me set them into a variable real quick. Equals get docs. So now X contains all the documents. If I do X, if I want the first document, I'll do X sub 0, right? The 0th document. Would you like green eggs and ham? Okay, X sub 3, for example. Would you like them here or there? 0, 1, 2, 3. Okay. So this is a key idea. The way that we've split up our documents into these separate values inside of an array, this lets us consider the index of that array as the document ID. We can always get to the document as it's stored in our array by using the same ID. That's its sort of hard address in our collection. This is great. Remember, the steps of indexing is that we're going to be building a set of postings to be able to use to pull out information from our documents. So, next step. We've got our documents split up, but they're still as they were. So we're also going to need to normalize all of our documents, just like we did before. So you see each one has been, cleaned up, the punctuation's been removed, extra padding on the strings, for example, has been removed. And then from there, we're going to do the same thing we did last time again, split them all into tokens. I've recolored some of the scheme to be more in line with what we've seen in the lectures. So now our documents, the tokenized set of documents is going to be a list, an array of arrays of tokens. Oop, let me not go so quick. Okay, so this is the first document tokenized into its terms, and that is once again a list. So let's pull out this set, the tokenized term document. All right, so X sub No. We don't need X anymore. X is the original documents as in their raw text form. Let's do var y is, we're going to go get, the name of that one is docs tokens. Great. Okay, so y contains, if we do y sub 0, we're going to get the first set of tokens, but that is itself an array, so we can do y sub 0 sub 0 to get wood, the very first token of the very first document. We can get y sub 0 sub 1 to get the second token of the first document. This is less critical to the way that we'll be working with things for now, these positions, right? But if we get into positional indexes, this becomes very important, because this can be used to say, oh, that is the position of this particular term in this particular document. Document ID 0, term position 1 is U. So, finally, we're going to run through all of these tokens, and we're going to do our indexing process. Our index is, it's hard, it might be hard to see it initially, but this is a hash table, and or in JavaScript just known as objects. It's sort of generally thrown in that all objects are just also hash tables. But that's important. So hash tables work like this. We're going to say, let's make one. In fact, I'm going to reload and ditch all what we've thrown in there so far. Okay. So var table. We're going to say it's just empty, right? This is an object, also known as a hash table, also known as a dictionary in some places. The whole point is this is the data structure we will be using to contain our index. How? Well, let's look at how one of these objects works to begin with. So, table is just an empty object, an empty table right now. If I want to give it a value somewhere, I can say, very similar to the way we were indexing into the arrays, I can say stuff, table sub stuff equals 1. So now if I look at my table, it has a key value, and it has a value in that key value. Let's do something else. Table other stuff. Well, what if we want that to be this string? Look at our table again. Okay, so if I want to get one of these out, if I say table sub stuff, we'll look at that. We can pull it out, table sub other stuff. Okay, so table stuff, table other stuff. Stuff and other stuff are words, are full strings. Remember, we can index into this structure using strings. Those are our terms. What's stored in them are postings. So we can build something like this. Let's say table. Let's clear it out. Let's make table equals nothing again. Great. Well, remember what postings are like. There's something like table sub would be our term, equals, and we won't be doing them all at once, but something like, remember what are we using as the document IDs? The indexes into those original documents. So 0 to 5, etc. Right? Table. So I'm making that up. Actually, let's not make it up. Let's do it with our human eyes. Where does would leave? Or where does would live? It lives in document 0. It lives in document 3, 4, and 5. Okay, so table sub would equals 0, 3, 4, 5. So now, if I want to use this table, this index, I would say, hey, for the term would, what documents is it in? Well, here we are. It's in document 0, document 3, document 4, and document 5, which point to document 0, document 3, 4, and 5. That's where they live in our structure. That's where they live in our information retrieval system. Those indexes are exactly how we will use document IDs to get documents. So what we'll do is we'll build one of these tables up from the terms, and ultimately we'll end up with this structure, which is terms, 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 terms. Now, initially you might think, oh, hey, what's the why are the indexes, the keys, right, the terms, they're not sorted? Aren't they supposed to be sorted? Turns out that's a quirk of hash tables. It doesn't matter, because we're never going to be searching through them. We don't need the actual terms to be sorted in a hash table. They will just index directly. So we get a lot of nice free things out of the way that we build these indexes just from using an actual hash table structure. So let's do it. Well, first let's do a little, I have a cat. Her name is a little bit, right? Even simpler example of how this works whilst working. I have a cat. Her name is a little bit. Normalize. I have a cat. Her name is a little bit. Tokenized. I have a cat. Her name is a little bit. And then the documents and their postings. Also, don't worry that these are strings. In JavaScript, it still works. So, no fuss. I have a cat. Her name is a little bit. Okay. So, that's what we're working with. You'll be able to get this, again, you get the shell document, the front-end document from the website. And let me reload, cleanse the palette. And we will then be building these functions to achieve this. We can look real quick at the update function. I have cleaned it up just to remind you how the front end works. So remember, every time you start typing in here, stuff, some other stuff, right? The update function is called, and it will do all of these, right? It will convert the raw text field. It'll call your split documents function on it to get the docs. That's what's stored in docs. We'll take docs and call normalize docs on it to get the docs norm, cool. We'll call we'll get docs norms value back. We're going to tokenize that structure, and then we'll put that into docs tokens. And then docs tokens, we're going to index. We're going to run one giant index function. Yes, that's all we'll be writing, and it's not especially long. It is a little dense, so we'll be spending some time on that. And then ultimately the index is what the output is. Once we have an index for future stuff, we can then use this to actually process queries, find postings, take intersections, get a set of documents that match. We'll be well on our way to Searchdown. So that's the high-level walkthrough of what we're supposed to do here and what documents or what functions we'll need to define. So now, as always, we take my working file and we throw it right in the trash. Reload the page. Oh dear, everything's broken. That's good. So we're going to rebuild it from scratch. Let's see. So again, you'll want to download the HTML file for the second system page that we're building here. But for the library, you're just going to want to copy it over from your last assignment. Oh, shoot. It went into the wrong folder. Okay, there we go. Blue. So, again, this is Finder, just like my file system, and this is my text editor, which also happens to have a nice file system attached to it. You can get that kind of stuff out of Atom, Notepad++. I use BBEdit when I'm on Mac. All good stuff. So, why do we copy this over? Well, it's because we're going to reuse some of these functions. We're going to make our job easier. You know, I don't want to have to. It's a lot of work to process a whole set of documents, especially if you have more than 6 small lines. We want to reuse everything we can to do things quickly. So let's first, before we start doing all the new stuff, I want to address a couple of cleanup ideas here. So having well-organized code and maintaining a library is pretty nice. For now, we're going to do it sort of in autobiographical mode, but I want to do a couple of things. I want to clean up the code and offer a little bit of documentation in the code for future us, for future you, so that you know what the heck all of your old functions were. Because no one hates current you more than future you in programming. Because the things you do now will cause future you many headaches. So we want to try and be kind to future us and set things up so that they're a little bit clear. So, first of all, one thing what we want to get rid of, the way we left it last time, we left some console.logs in. We don't have to necessarily delete them, but at minimum, comment them out. We just don't want to have our log cluttered up with processing stuff from last time. Because it's really good to put console.log and check, hey, when this function fires, just kind of dump a string out here, show me what's going on in this variable, right? But when we finally run our systems at a later date, we don't want all that stuff cluttering up the log. So comment out any console.logs. What else do we need to do? Everything else seems kind of clear and clean. Tokenize, tokens, good. Okay. We also want to kind of start breaking up the file, so we'll start with that. This from here on will be assignment 2. Functions. We'll put a little note up here that these were assignment 1. Functions. But they're all going to be available to each other because they're all going to live in the same file. Also, let's give ourselves some notes. This is important. These don't affect the way any of the code works, right? This is all notes to you and future you and me to an extent. So we want to keep note of what these things do. Trims off the edge of a piece of... what's a better phrasing for that? Trims off the white space on the ends of a string, right? Give yourself a human-level description of what these things do. Converts a string to lowercase, right? Strips out all punctuation from a string, right? Normalize, okay. So this is a little more abstract, right? It's multiple things that we're doing all at once. So normalize a string into term-ready form. Sure. And you might also want to put some comments within. In fact, I'm actually going to go ahead and delete these just for cleanliness' sake. Just always know that you can insert console.logs to check on things. So this is clean. And in fact, these are pretty straightforward. They are meaningful inherently because they do so little, right? Okay, that's good. So then this turns any given string into a normalized form. Finally, we want to tell what tokenize does, but also talk about what it takes, right? So takes a normalized string, outputs the string as arrays of tokens. Right? So if we called tokenize now, and let's do it, right? Still a bunch of stuff is broken, but hey, at least it's reading the file properly now because it's in the same folder. So again, remember, you can always open that file right here in your browser to see what's going from here or from your text editor. So, and just to remind ourselves, how does tokenize work? If I tokenize A, B, C, D, E, there we go. Okay. You can always do this. We are writing functions that work just as happily over here as they do when we call them in the code. So, okay. Quick refresher to ourselves again. So we got tokenize, that works. But remember, we got to normalize strings too. So if I give normalize, right? Okay, cleans it up. We can then tokenize it. Cool, 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 cool. We are getting back on track. Okay, so that's our set of functions from the first day. Let's talk about the functions we need to find now. So, pull back over here. We need split documents. What's it going to take? Just some text. Normalize documents will also take a set of documents. Okay. So let's make some definitions. What's our very first step? Function split documents, right? We'll just even copy the name over. Function is split documents. Great. And what's it take? It takes raw text, right? So, what are we going to do here? We're going to take this raw text, which could be anything separated by carriage returns, right? New lines. These are all separate documents. This process is going to be very similar to the tokenization process. If we look at tokenize, we take a string, right, and we split it based on some criteria, regular expression criteria, which again, I will give you the exact one that will solve this, but we'll talk about how it works as we do it. So, what do we do? Well, as usual, let's do a let, say, text inside this function. That'll be the raw text. Why do we do this? Sometimes it's good to just make sure that you're getting a full, not editing something that's being passed through. You're getting it stored directly right here. We're not competing with other names. We're not getting confused. This, we are defining for the duration of this function. We are going to refer to this as the text, but we're going to take it out of the argument. You don't always have to do that. You can just use the raw text argument too, but this is just a little bit more clear and a little bit more safe. So, how are we going to split the documents up? And again, it's almost identical to the tokenized process, but we want to give it a sort of a specific shape. So, the way I've defined it right now, a document can have multiple lines if it wants. But as soon as we get 2 new lines in a row or more, it'll split off into a separate document. So, to do that, let's say let docs equal, we're going to use split again. So we're going to split text. That's the raw text that's coming in. Dot split. But we need a regular expression now, right? Okay, what do we want? Well, first of all, we're going to do all of them. So we get our regular expression bars set, our delineation, and G, right? G means all of them, global. Get all of the things that match this. What do we want again? We want it if there's a new line character and another new line character, one or more, right? So, in regular expressions, new line is this, but we don't want to split on just every single new line. In fact, let me show you what happens if we do that. We're going to go ahead and return docs, right? So, let's load it up. Aha, okay, but here's the problem. These are empty strings. So what we can do, we can exploit this cool trick it's not even really a trick, it's a very basic function, but a cool thing about regular expressions is that you can say, okay, I need this new line character, that's part of the thing I'm searching for. I also want at least one other one. But to say at least one, you add a plus after it. So now we have guaranteed find me one new line, and then thereafter give me at least another new line. So let's look. Save it. Go to the browser. I guess I'll keep this kind of like this. That's fine. We can always, yeah. All right. Go to the browser, reload. Aha, it's working. It's working. Oh, it's broken. No, it's still broken. It makes sense that it's broken. This is the normalizing step that we have not yet coded for. Good, good, good. So, cool. Okay, so this set of text, it's working as intended. We have nothing but new lines. Any number of consecutive new lines are said, hey, that's just a space between documents. And then as soon as it finds another piece of text that's not a new line, it says, okay, here we go. It would break if you had a bunch of spaces between documents, so we could figure that out, but let's not fuss with that for now. For now, just the format that we're agreeing on for this input box is you must have new lines with nothing else in them. Okay, so now that's nice. We can paste anything in there that follows that same function, that same convention rather, and it will split it up into individual documents. Great. Cool. Okay, so now what do we want to do from here? Well, we have two other steps before we get to the meat of the indexing stuff. So we need to normalize each of these. That's not too hard. What's the name of that? We are going to be normalizing the docs. Also, just so it's clear, I did all this spacing out here just to make it a little bit clearer what was happening. So we're setting the docs box to be the value of whatever the split documents function returns given this doc. So we input the raw text, we call split documents on it, and then we set docs to that. So raw text, call the function, docs, right? Okay, so next step is to normalize all the documents. That's interesting. In fact, that's actually quite easy. One moment. Before we roll forward, let's continue our due diligence. Splits raw text into separate documents splits based on, oh goodness, here comes an email. Splits based on at least 2 new lines in a row. These are great. These are notes to yourself, notes to me, notes to anyone who's ever going to read this code. What the heck is this function doing? Let's make a note. For now, there are like very specified ways that you can write these that it makes them extremely clear. For now, I'm just saying you get used to writing yourself notes in a very kind of casual form. It's pretty important. My goodness, stop emailing me. Okay, so let's see, where were we? We need to normalize our documents now. So we have a bunch of separate documents. Great. Oh my gosh, get out of here. How do I disable it? I'll figure it out later. So we need to now split we have the document split. We need to now normalize the documents. So let's do. How are we going to do that? Well, this function, it's going to take normalizes each, we can spell, normalizes each document string in a set of documents. Okay, so we're going to do it based on a set of documents, right? Okay, how shall we do this? Well, as usual, let's set up a place to store some things. We're not going to be editing this one, so this time let's skip storing the docs, right? This function takes the docs and it's going to read each one of them and do something to each one, right? So let's not fuss with the capturing the text. So we're gonna let a set of new documents, well, new docs we'll go with. Not a function, sorry. So what are we doing? We're taking an array of documents, we're gonna do something to each one of them, and then we're gonna output, yet again, an array of document strings. So make an empty array. Cool. Now, what are we doing? Well, we want to walk through the set of docs that we received in this at the start of this function, so these, and we're going to normalize each one of them. Now remember, we've already got a process for that. It's called the function normalize. You wrote it. You've got it. So let's write a for loop to do this. So let's see. We haven't touched on the looping yet. Okay. This is an important structure in programming, the loop. For loops are quite nice, and there's a few varieties where we won't linger too hard on the very explicit versions, but there's two that we should talk about today that are useful. So in JavaScript, let's say I want to print, I'm trying to think here. Let's say I want to walk through a list. Var x equals a list of things. 1, 2, 3, 4, 5. No, let's do 100, 200, 300, 400, and 505. So, x, blah. Let's say I want to just walk through and print each one of those, right? So for x, no, sorry. So we have x. We have this list of values at each of these indexes. If I just want to grab the value, I can do this. For val of x. Now, what have I done here? This is arbitrary. Val is just a variable I've defined for this for loop. It's just a name I've given. Of, though, says, hey, so we're going to grab every value out of x, and we're going to do the same thing on each one. What's the same thing that we're going to do? We're going to do console.log val. So val is the name of whatever was in the x array. And then if we do this, oh, for value of x, that says go and grab me the actual value out of this array. We can also do for, I'll call it ix for index. I want to be careful with index because we're talking about two different kinds here. Arrays, classically, you use the index to get into them, right? So x sub 0 is the index. Index 0 of x is 100. Right? I'll call it address. For address in x. What if we do this? What if we print the ADR? Console.log ADR. Right? This is not going to print the values of x. It's going to print the indexes of x. This is useful. These are two different ways of stepping through the list. Now, I can actually do the same thing again. I can replicate the of loop, the for of loop, using this. I just have to use the address, which we know is, the key value, the index value, x sub its address. This will do the exact same thing as the of loop. It's going to go through each one, each item in x, and it's going to say, hey, give me the address, give me the index of that value. I'm going to store it in ADR. Then I'm going to go and log x sub ADR. Get the values out. Both of these are quite useful. We're going to use both today. That's why I had this aside on them. So the idea is these for loops, and especially the ones we're using right here, they're custom built to make it very easy, very quick to just run through a set of things and do something on each one of them. So, what are we going to do on each doc in docs? We're going to convert its values, its strings. We don't really care about its addresses right now. Convert each of its strings to the normalized form. Let's do that. So, for D of docs, we're getting the values, right? We're just kind of skipping the addressing. For each thing there, for each document, I want to var new doc. Norm doc equals. We're going to say normalize D, right? So let me grab the values out and show what's going on here. So again, you can also do this. Go and toy with it in the console. So var x, I'm tired of x. Let's say docs equals. We're gonna go get. What's the name of this one again? I should really label them with their actual literal IDs. I'll do that next time. It's just docs. Okay, so we're gonna go get docs. That's the ID of this box here. Go get it. Go get var docs. So now docs contains all of our documents. Cool. So now what I want to do, I want to show is how we can step through this, right? So for D of docs, console.log D. Oops. Shoot. Ended it with a parenthesis instead of a curly brace. That's an important little syntax step. For loops, ifs and fors and most control statements have curly braces as the way that they will open up for code, just like functions, right? Now, here comes a new block of code is typically what the curly brace means, unless you're doing an index. So, okay, check it. So for D of docs, we logged the document. So would you like green and ham? I did blah, 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 blah. Okay, great. What if instead we log the normalized form? Hey, that looks familiar and good. Cool. So we are saying I'm just going to log out the normalized form. So we'll go back here. So we're going to define, well, instead of var, let's do let. Let is the more restrictive version. My apologies. So let normdoc equal normalize D. Push, no, sorry, new docs.push. So this is how we can accumulate something. We can say, hey, new docs is an array. In fact, as usual, let me just go show you in here. So reload, clear the slate. Var x is an empty array. X.push 1, X.push 4, 5, mistype, X 1, 5, X.push 17. It always returns the length when you do push, but you don't have to do anything with that information. You can just use it to add the item to it. So every time I use push, I add something to the end. Perfect. Because we're walking through each document, we normalize it, and then I want to pop it onto the new stack of documents. Let's do it. New docs.push normdoc. Okay. And finally, we've built this new set of documents, this new set of normalized documents. In fact, sorry, I'm going to keep doing this stuff just so you know it's okay to go back and refactor things a little bit. Norm docs, right? Not just new, norm. We want to be clear with ourselves. So we start the function, normalize the documents, given some docs. I go through, I set up a new bin of documents, a new array of documents. That's the place to hold them. And then we walk through the documents. We normalize each one, store it in a temp variable, and then save it, push it to norm docs. So now we will say return norm docs. Reload our page, see if it's working. Yeah, all right, here we go. So, would you like green eggs and ham? I would not like an email now. I would not like them anyhow. So, cool. Hey, it's working. This normalized docs function has taken. Come on, get out of here. Get out of here. It's taken the raw, well, not raw, the parsed out documents. It runs through each one and it calls our normalize function on it. These are all clean and ready to be tokenized. Great. So let's start that. Okay. What's the next function named? Tokenize docs. Just take it, make sure it's exact. Okay. Tokenizes a set of documents by splitting on white space. Right? Yeah, I should actually give us a note there by splitting on white space, right? Just to remember, that's what we're doing. Okay. So, how are we going to do this? Function. Tokenize docs. A set of documents is what it takes. And, well, we're going to do let... We need to, again, we're going to step through this thing. We don't necessarily need to define a new version of docs. We're not going to edit it. But we may want to... We still want to have a bin, just like we did for the normalized docs. In fact, this is a very similar process. So let token docs be an empty set, an empty array. And then for D of docs, once again, because we're just going to, how do we tokenize, right? What do we need to do to tokenize? Well, it takes a normalized string, splits it on the white space, and returns it as an array of tokens. Cool. So that's fine. This token docs is going to be an array of arrays of tokens, right? We're going to take one of these nice clean strings, and we're going to split it into an array of tokens that we'll then use to index. Okay. So for D of docs, once again, we'll do let token doc equal tokenize on the D. All right. So now token docs dot push, as always, token doc. So the reason I'm just kind of blasting through this one is that it's the exact same process. We're just, instead of normalizing the string, we're tokenizing it. So we can kind of skip all the quick checks and just assume that we're doing it right for the moment. And check once we get to the end. Return token docs. Okay. Reload it. Okay. So, did it work? Would you like green eggs and ham? Okay, so this is an array of arrays of terms. Would you like green eggs and ham? That's document 1. Great. I do not like them, Sam. I am. That's document 2. We're there. This is, if I go and get, once again, got to keep checking. It's called docs tokens. Okay. Get docs tokens. And as usual, we should just save it real quick into a variable. Okay. X. It's an array of arrays of tokens. That's what we want. That's perfect. So this makes it so that we can step through each document, and these are still in document order, right? And we're going to do the inversion process, the indexing process. This is clean. This is ready. It's ready to go. Let's do it. Let's do the index. Okay. This one's trickier. And it's a little more involved. So, yeah, let's knock it out. We finally need to build our term document index. Whoa, how do we even start that? Well, let's talk about the basics, right? If you remember, the way we've talked about term document indexing before is we're going to do all this stuff of record occurrences. Sorry, I'll put this into these just so you don't get used to typing freely in your code. Record occurrences, sort, merge. A lot of this has actually been made obsolete by the fact that we're using a hash table. We're going to be building a hash table, so sorting our terms no longer matters. And also, because we're going to be stepping through our documents linearly, we kind of don't really need to sort the postings either. We're just going to record them and push them onto the end of the list one at a time. So we can kind of skip some of these things. We're maintaining the concept of each one of these, but we're sort of skipping over some of the effortful bits because we don't need them anymore. So we're not really going to sort. More it's about we can just kind of do a lot of these together on the fly by using a little bit of logic. So if we're going to maintain this idea, what we still need in the end is something along these lines, right? We need to have an index of term A is going to contain postings for 0, 1, 5, etc. Term B will have postings for 1, 2, and 7. Term C will have postings for 5, 4, and 9, 49, 49, blah, 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 blah. Okay, whatever. This is a viable index. This is the structure we're looking for. The postings exist, and remember, each one of these is going to be an index into our document array. But how do we get them recorded? Right, so we can because we don't care what order the terms are in a hash table. We can just walk through each one of these things. We can say, "Hey, would you have occurred?" So I'm going to make sure there's an entry for would here. In fact, let's do it live in the console. All right, so we're gonna make an index, right? Var index equals nothing. Okay, so let's walk through and start doing some stuff. Okay. We're going to skip around a little bit. Let's do would you like, right? So, index sub would. First of all, does that exist? It's undefined. If I try to index that directly, I'm going to have to do some if statements to check and make sure it exists first. Because if it doesn't exist, we need to set it up. We need to give it an empty set of postings. So, index sub would to start doesn't have any postings. So we'll make it an empty array, right? Okay, but now that we've created the empty array, well, index sub would contains an empty array, so we can push document index 0. The document ID for this first one is 0, right? That's how we would get to the 0th term. So we're going to push the value 0. Okay, so now if I look at the index, would contains just 0. Great. Let's do the first. Let's see. I'm trying to find the next one. Okay, let's do u. Index sub u. Of course, we know it's also nothing's in there yet, so we'll go ahead and make it empty. Index sub u, and then index sub u dot push. Also document 0, right? We're still in document 0. Okay. Index sub like equals. We know it's empty. We're on the first round. Okay, index sub like. Okay, so index like dot push. Again, we're going to push 0 onto it because that's the 0th document. Okay, let's skip ahead a little. Let's do skipping to document 4, right? Let's assume documents 2 and 3 had all other words. Who cares? So now we're on document 4. So sorry, 0 1, 2, 3 is the ID on this one. So, okay, first token is wood. Wood. Index sub. Index sub wood. It exists, right? So we can skip the setup step and just push document ID 3 onto it. So now let's look at our index. 2. Oh wait, what did I do? Index sub wood. Oh, I pushed. I pushed this confusing thing, an array with the value 3 index. Let's check what's in index sub wood. Okay, it just broke. That's fine. That's for the best. Index sub wood dot push the value 3, not some weird addressing thing. Okay, so let's just look at the index. Okay, here we go. Like contains just the one reference so far, but wood now has 2 postings. This is the exact process. We're going to go through each one and we're going to add it. We're going to go through each term and add its document's ID to the postings for the index. Okay, let's clear the slate. Still broken. Good. Let's do it. What's it name? Index docs. Let's do this. Take an array of documents, tokens, no, of documents as arrays of tokens themselves, and output a hash table JS object. Output an index as a hash table JS object. So, function index our docs. We're going to take docs as tokens. Actually, let's for clarity, token docs, right? So these are documents that are tokenized. They need to be that way, otherwise this function won't work. Okay, let's start. And I will be leaving some what's the word? Some comments inside this one because we need to really keep a map of where we're going. So let index equal an empty hash table object. Great. So now, what's our first step? These things are not going to be intuitive, so follow along carefully. I'm giving there's some wisdom baked into some of the decisions we're making here. So, first, we're going to step through each document, right? We're going to walk through all of the documents, or rather all of the documents. But what we really need to know about each of these is we need to keep track of their ID. Remember, we had for of can get the content, but for in gets you the IDs. So, step through the documents IDs, right? So for doc ID in token docs, right? We're going to do a bunch of stuff, right? So this means that for every document ID, i.e. the index of the highest level here, right? So this is at index level 0, index value 0. Sorry, the term index is so confusing. At address 0, doc ID 0, these are the tokens. This is also, that's the same address as where this lives in the collection, in the actual document collection. So we will make that happen. Doc ID in token docs, great. So that's the first step. We now have the document ID. What we're going to do now, remember, is we're going to walk through and say, hey, for each term that I find in this document. So go ahead and cut off the information there. Well, no, let's finish the thought. So for each term in this document now, so we have the document ID and the token doc set, I can get out this set of tokens. For each one of these, I'm going to do some stuff to add it to the actual index. I'm going to add this document ID to all of the places that these terms live in the index. So let's do the next. We're going to have nested for loops here. So for each document ID, and then for each token in that document, step through each token of that document for TKN, we'll call it, of token docs. But not the whole thing, right? We want to get the doc ID one, doc ID, right? So what is this doing? This is saying I've got the doc ID, I need to preserve that value. And I'm walking through all of the documents. Great. For each token within the tokens living at that address, so for each of these, right? For token of token docs doc ID, we're now going to be able to walk through each of these, which I've gotten to by saying token docs to doc ID, and we're going to pull them out and ask questions about, hey, are you in the index or not? If you're in the index, I'm going to just add my doc ID posting to the end. So this might help, might be clearer. No, this is okay. Let's just continue. So, okay. We're doing a double loop, right? We're going to say for each one of these, and then for each one of, so for each document, and then within that loop, for each token, right? For each term. What am I going to do? The same thing we did when we were doing it by hand. We're going to say, okay, wood. First question, is wood in the index already? If not, I'm consulting a little bit of a cheat sheet just because I've solved some of these things. We're doing them in a fairly streamlined way. So if the token is not in the index, ooh, that's a loaded concept right there. Let me try to break it apart. So in kind of serves multiple functions in JavaScript and many other languages. It's sort of an intuitive idea of, hey, if I say var x equals 1, 2, 4, right? I can say, hey, is 1 in x? Yes, 1 is in x. Is 3 in x? It is not. It's important to separate this from the way that you use it in a for loop, because this one's talking about content while this one's talking about addresses. So just remember that it is very distinct. For in is a very different idea than the sort of logical, is this thing inside this? So TKN in index. You can also do it as an index, right? So var y, no, we'll call it the var index, equals A has 5, B has 6. I can say, is A in the index? Yes, it is. Is banana in the index? No, it is not. But if I said index of banana equals 70, now banana in index, oops, I asked use the actual question mark. Yes, it is. Okay, so this is saying if the current token, i.e. wood, is in the index, that's going to be true. But we want to do something only if it's not in the index, right? So we invert it. We use the not. So is not banana in the index? Great. So banana is in the index, but we're asking for the not. Because in an if statement, we're saying, hey, do this as long as this statement is true. So if the token is not in the index, and I'll write a note, if the token is not in the index, then we need to make a space for it, right? We need to start the postings. So, actually, wait. Yeah, okay, we're good. Index sub token, right? Because we're saying this is the index, and we're saying the token would is the way that we get into it. Assign it to a new empty array. This is where we will store all of the postings. So, you gotta open the brackets. I didn't do that. So, this, right? And I'll make a note here. What are we doing? Well, we're saying, I'll make a little bit of space each time I do this. By the way, indentation is your friend. Don't neglect it. In some of your editors, you can set it up to automatically indent. I recommend you do that. These things are not sensitive, like the code is not sensitive to indentation. Your eyeballs are. So try to get some indentation going for your own sake. So okay, if the index has that token already, or if the token doesn't exist yet, set up an array for postings, right? Else, no, we're not elsing. This is just, if that's the case, we have to do this special step, right? If the thing's already in there, the next question is, we could just go ahead and add it straight away. We could say, oh, if I would add the document ID to these postings right away. I could just do that right now. In fact, I'll just show you how that looks. So, good. We've given it a space. If it didn't exist already, then immediately we could say index sub token dot push our doc ID. That feels triumphant. But is that all? Well, let's just see it as it is. Okay, so we've gone through all this effort. We have set aside an index. We've said, I'm going to go and look at each document, but I'm going to keep track of it in terms of its ID and not its actual content. And then we're going to go through each token of each document and say, hey, is this token in the index? If not, I'm going to build some postings. Then I'm going to move on and just say, hey, put this doc ID in the index. Okay. That loops. We go through each one, we loop down, do it over and over and over and over again. We go back, we do it over and over and over again for each one of these, and then each one of these, and then we get to return our index. Does it work? Oh my goodness. Oh my goodness. Why was I even going to do any other stuff? It works. This is great. We have gotten to the point where we have our terms and the IDs of the documents, where they live up here. That's great. That's fantastic. But there's an issue. Would you like green eggs and ham? Oh, right. If we recall, we are not keeping track of document frequency, and it actually just kind of makes things all messy if we do them for now. So we need to check to make sure that the document ID that we are on isn't already in the set of postings for each of these. So right here, before we commit to just going ahead and pushing the doc ID in there, we need another if. Now, we will probably revise this in future versions where we build other kinds of indexes, but for now, we skip this. So, now, if this doc ID is not already present in postings, so let's do it. How do we do that? Well, we can do it this way. In fact, this is the more official way to check what is inside of an array, right? We're working in arrays with the postings. So, I don't need to type postings. I'm just vomiting. I've been going too long. We've got to stop soon. Okay, so what were we doing? Let's see. Oh. Here's the way we can do this. So var x equals 1, 2, 4. I know we just did this a different way, but this is, I remember it being key here. So we need to say x dot includes 4. True. X dot includes 7. False. Okay. Very similar to 7 in x, or 1 in x. But this kind of default way to do this when you're working with arrays can get kind of screwy, especially if these values become zeros. So skip that in concept. What we need to do is ask, is 1 in this, and we use the includes method. So x dot includes. So what we're going to do is say, if this doc ID is not already present, okay, so not, we start, didn't type it, not index sub tkn, right? That's the token that we're on. Or no, sorry, that's the index's postings, right? Dot includes this doc ID, right? What is this saying? What does this say? If the postings from the index for this token already has this doc ID, then we want to skip, right? So if we're only going to add it if this is not true. So this doc ID is not in the postings, then we will push it to the postings. Push the current doc ID to postings for this token. Okay. This is an intense function that we've built up over the course of this hour, and let's see it. Let's do our test. Would you like green eggs and ham? The answer is sure, whatever. It didn't show up multiple times. We have stopped it from happening over and over again. We still process each one of these. We say, hey, oh, but you're already in there. I'm not going to push another version of this doc ID into these postings. We get to again. Oh, you're still there. I'm just going to skip. You're still there. Going to skip. Green. Okay. I make a new space for you. Oh, yeah, that's good. Let's go ahead and add you. So that's it. That is the steps to create our own documents indexing system. A little bit broken when there's 0, but let's do abba bab. Okay. Abba bab. Normalized, they're fine. Tokenized, great. Abba happens in all of them. Cabba happens in the second 2. Bab happens in the third. It's robust to the enters. good. Makes the same index. Even if we change capitals, it's fine. Good. Great. This is good. This is a workable index because now I can do very simple things like say, let me go snatch the index out. So var index equals get our term document index. Right? Index sub, I want the postings for BAB. It's just that one document. My search also needs to have index, I want the postings for ABBA. Which document has both ABBA and BAB? 2, not 0, not 1, 2 and 2. It turns out that, close, what are you doing? So now if I ran the query BAB ABBA, which we don't have any way to do yet, but that's the idea. We will be building that. BAB ABBA. We would then we would grab these postings for each term, and we're going to go and do the intersection algorithm. And what we end up with is 2. We can see that ourselves. So now if I want to get what document is that, what document it lives at ID 2, let's go get docs. We'll put it in a var docs equals, go get the docs. Docs sub 2 0 1 2. That is our document. I just manually processed a query using this index, but I hope this makes clear what we've been doing here. We are building the postings for the terms in our dictionary. This is a standard index, and this is, once again, the beating heart of any information retrieval system so that you can do things like go get me all the documents that have ABBA and CAB and BAB. Okay, that's it. A lot of steps today. A little cleanup step. Let's see if there's anything we need to say here. Might want to put notes. It's usually good to put notes above for loops. Like, what are we doing here? For each document, normalize it. If you can kind of fit it on one line, that's fine. That makes it a little bit easier, especially if there's not actually a whole lot of density going on inside. We'll do the same here. For each document, tokenize it. Okay. Just notes to ourselves. What's this loop going to do? Well, we can check here real quick. Good. What do we do today? We split our documents up. We normalized each document. We tokenized each document. Oh, shoot. Did I just open numbers or something? We're going to find out if it pops up. And then we indexed based on those tokens. And we built an index that meets all our criteria. They are merged, right? That was this step. We were making sure that we didn't have to do a merge after the fact. We can do it beforehand as we're adding them. So there's a merge, right? They are not, these ones are in alphabetical order. Oh, no, they're not bad. But remember, that doesn't matter because we're not going to be searching the tree at all. We're just going to be indexing directly into it. Because it's not a tree, it's a hash table. Okay, that's it. I've gone on so long today, but that's our functions. So split documents, normalize docs, tokenize docs, and index docs. We use some of our old functions from before, from assignment 1, and we will definitely be using these functions again in the future. So that's it. Take care. Talk to you soon.